In this video, we are going to solve problems whatever you have learned so far. That is, we are going to solve problems on 1 by a square plus x square type of problems. Previous to previous video, whatever we had studied, that one. And also whatever we had discussed in the previous video. That is, what if you have px square plus q divided by ax square plus bx plus c. That is, you have a particular linear polynomial in the numerator and a quadratic polynomial in the denominator. Suppose if you have these type of problems, all right, well, how do you go about it? That you are going to see in this particular video. Okay, let's start with the first one. See what we have here: 1 by root of 2 minus x whole square plus 1, which is a very direct problem. Yeah, see here, now what you have is integral of 1 by root of 2 minus x whole square plus 1. Basically, 1 is nothing but dx, correct? First thing what you do, you substitute. That means take 2 minus x as t. If you take that, then you are going to get minus dx is equal to dt, or dx is equal to minus dt, right? So if you integrate this, you will get minus integral of dt over root of t square plus 1. Remember, this is I value, right? What is 1 by root of x square plus a square? Log of x plus root of x square plus a square, correct? So in this case, we will get I is equal to minus log of t plus root of t square plus 1 plus c. But what is t? 2 minus x. So I is equal to minus log of 2 minus x plus root of 2 minus x whole square plus 1 plus c. See, this is the answer for the first one. Very direct application of the formula. Alright. Now, in the next one, we'll solve the second one. See the second problem now. Again, integral of dx over root of. See, 9 can be written as 3 square. So we have 3 square minus 5x whole square, correct? Very simple. Now, since you have a coefficient for x, what do? We take the 5x as a t, right? So, substitution, take 5x as t. 5 times dx is equal to dt, right? So, dx is equal to 1 by 5 dt, right? Since you have this one, if you substitute, you will get I is equal to 1 by 5 integral of dt by root of 3 square plus t square, right? Oh, sorry, 3 square minus t square. It's not plus, it's minus. So now, what is 1 by root of a square minus x square? It is sine inverse, correct? So this is going to be 1 by 5 sine inverse x divided by a, t by 3 plus c. What is t? 5x. So I is equal to 1 by 5 sine inverse 5x divided by 3 plus c. So this is going to be the answer for the second one. All right. Now moving on, we'll do the third one. The third question, integral of x square dx over root of x power 6 plus a power 6. Now, one thing I want to tell here is that directly you won't be able to do any substitution whatsoever. So first you need to reduce this problem and then do the substitution. So what I mean by reduce and then substitute is, we can write the x power 6 as x cube whole square. right? Same thing, a power 6 can also be written as a cube whole square. So we can write integral of x square dx by root of x cube whole square plus a cube whole square. Now we can do substitution. That is, take x cube as t. So 3x square dx is dt. So x square dx is going to be 1 by 3 dt. We substitute this in the integral. So you will have I is equal to, first, 1 by 3 integral of dt over root of t square plus a cube whole square, right? 1 by root of x square plus a square formula, the log function, right? So I is equal to 1 by 3 log of t plus root of t square plus a power 6. Let's keep the a power 6 as it is. Now what is t? T value is x cube. Substitute. So if you substitute, you'll get I is equal to 1 by 3 log of x cube plus root of x power 6 plus a power 6 plus c. So this is going to be the answer. Fair enough? Now we are going to do the fourth one. All right. See the fourth question now. Now I think by looking at it only, you will get to know that what should be the substitution part, isn't it? So you take tan x as t, right? So here directly take tan x as t, then secant square x dx is equal to dt. Direct substitution, nothing more, nothing less, right? So now you have integral of dt divided by root of t square plus 2 square, correct? Again, we have to use the log itself, just like the previous one. So when we use log, you get this as log of t plus root of t square plus 4 plus c, correct? So what is t now? Tan x. So we can write I is equal to log of tan x plus root of tan square x plus 4 plus c. So this is going to be the final answer for the fourth one. All right. Now let's do the fifth question. The fifth question, see, you have 1 by root of x square plus 2x plus 2, right? Now, if you remember, we had solved these type of problems once, right? So previous to previous problem, I had shown you how to go about it, right? So let's do a simple recap of that, one. You have to write the denominator as a whole square, correct? That's how you're going to solve these problems. So here, you have integral of dx over root of x square plus 2x plus 2. So the denominator x square plus 2x plus 2. Now we can write this as a square plus 2ab plus b square, correct? If you compare, a value is going to be x, right? Next, 2ab is equal to 2x. Now a value is what? X only, right? So 2x into b is equal to 2x. So b value becomes 1. So when you have b square, we add 1, we subtract 1, right? So this is going to become x square. So first you have x square plus 2x plus 2 this can be written as x square plus 2x plus 1 minus 1 plus 2. Correct? You add 1, you subtract 1. Then you group it. So you're going to group this one. If you group this is x plus 1 whole square plus 1. Isn't it? So this becomes the denominator. So the integral is going to become I is equal to integral of dx by root of x plus 1 whole square plus 1. Right? Substitute. Substitute what? X plus 1. And x plus 1 you're going to substitute as what? As t. So we have x plus 1. Let this be equal to t. So dx is equal to dt. Right? So finally, the integral is going to become I is equal to integral of, the numerator becomes dt. So dt divided by root of t square plus 1. Again, it's a log function. So we have log of t plus root of t square plus 1 plus c. But what is t? X plus 1. So we get log of x plus 1 plus root of x plus 1 whole square plus 1 plus c. Correct? So this is going to be the final answer for the fifth one. Yep. Now we move on to the sixth one. See question number 6. 1 by root of, so integral of dx over root of 7 minus 6x minus x square. First take the negative sign common. That doesn't mean you write root of minus 1 is equal to I. No, we are not doing complex numbers whatsoever. Within the root itself, take the minus sign common. So that you can solve the quadratic polynomial much more easier. That's the only thing what we are concerned about. Fine. So this particular problem, you can write this as integral of dx root of minus of x square plus 6 minus 7. Now we take that x square plus 6x minus 7 and convert that into the whole square form, just like what we did in the previous case. All right. So what do we do now? You take x square plus 6x minus 7. So equate this or compare this with a square plus 2ab plus b square. So when you compare, you can get a is equal to x and 2ab is equal to 6x. Right? So we have 2x into b is equal to 6x. This is 3 times. So b value is 3. Right? So the formula, you have x square plus 6x minus 7. So this is going to be x whole square plus 2 into x into 3, 2ab plus b square. You cannot just add b square. So minus 9 minus 7. Then take these things together. Right? So you get x plus 3 whole square minus 16. Right? So the integral now becomes I is equal to integral of dx over root of minus of x plus 3 whole square minus 16. Correct? Now you take the negative sign inside the bracket. So when you take the minus sign inside the bracket, 16 becomes positive, x plus 3 becomes negative. Correct? So now the same integral value will become I is equal to integral of dx over root of 16 minus of x plus 3 whole square. Correct? This is of the form a square minus x square. Correct? Now, before that, substitute x plus 3 is equal to t, dx is equal to dt. Right? So, I is equal to integral of dt over root of 4 square minus t square. What's the formula? Sine inverse function, right? So we get I is equal to sine inverse of t divided by 4 plus c. What is t? X plus 3. So we get I is equal to sine inverse x plus 3 divided by 4 plus c. So finally, this is going to be your answer. Got it? So this is the answer for the sixth one. Now, in this one, we have finished the sixth one. Let's do the seventh one. This will discuss the seventh one. See here, integral of dx over, what do you do? The first thing is, what do you do? Take the minus sign common, correct? Just like what we discussed in the previous video. So you have root of minus x square minus 3x minus 8, right? Now, first thing, what do? You take this and compare, right? So, x square minus 3x minus 8, a square minus 2ab plus b square. So, a value is going to be x. Next, minus 2ab is equal to minus 3x. So, minus minus cancels. 2x into b is equal to 3x. So, b value is 3 by 2. So, we got a fraction. Fantastic. We got a fraction. Now, when you take this one, what do we have? X square minus 3x minus 8. X whole square minus 2x into 3 by 2. Add and subtract b square. So, plus 9 by 4 minus 9 by 4 minus 8. Correct? Now, when you take the grouping part, this is going to be x minus 3 by 2 whole square. Next, this is going to be, you have to take LCM as 4, correct? So, minus 9 minus 32 divided by 4, correct? So, you get x minus 3 by 2 whole square. Next, 32. So, this is going to be 41, right? But it is minus 41 divided by 4. This is the numerator, but not the entire thing because there is a negative sign. So, the value of the integral, now it's going to become I is equal to integral of dx over root of 41 by 4 minus of x minus 3 by 2 whole square. I hope all of you understood because there's a negative sign outside the bracket within the root. So we take that, we are going to get this one. Now, again, this is of the form what? A square minus x square, right? First is the substitution part. So take x minus 3 by 2 as t. So dx is equal to dt, right? So now you have I is equal to integral dt over root of, see, 41 is a prime number. You can't do anything with it. So we can write this as root 41 by 2 whole square minus t square, correct? Root 41 by 2. Now you can do a square minus x square. So you will get I is equal to sine inverse t divided by root 41 divided by 2. So the 2 goes to the numerator, correct? because denominator of the denominator goes to numerator. Now, I is equal to sine inverse of 2 into x minus 3 by 2 by root 41. Guys, you can further simplify this, like multiply the 2 within the bracket. So we'll get I is equal to sine inverse 2x minus 3 by root 41 plus c. This is going to be the final answer. Alright, 2x minus 3 divided by this one. Fair enough. So whatever we have done is for this one. So in the next one, we'll look into the eighth one. Eighth one. See here, this is of the form that px plus q by root of ax square plus bx plus c, right? Now, how do we do that? Numerator is equal to a into derivative of denominator plus b, correct? This is how we are going to do it. So, numerator, which is 4x plus 1, denominator, which is 2x square plus x minus 3. So, what do we do now? You are going to take the numerator. Actually, you guys can do it directly because numerator is nothing but the differentiation of the denominator itself, right? But still, because it is of that particular form, we'll apply that itself. That means numerator is equal to a into d by dx of denominator plus b, correct? So 4x plus 1 is equal to a into derivative of denominator, which is nothing but 4x plus 1 plus b, right? Now, if you look at this one, if you compare the coefficients and all, a value becomes 1, b value becomes 0, right? So the integral is going to become I is equal to integral of 1 into d by dx of the numerator, sorry, d by dx of the denominator, correct? So which is nothing but 4x plus 1 plus b is anyway 0, right? Divided by root of this one, 2x square plus x minus 3. So basically what did we do? We just take the denominator as t. One step you'll get the answer. That's it. Very, very simple. Alright. So if you take 2x square plus x minus 3 as t, so you'll get 4x plus 1 as dt, as in 4x plus 1 dx is equal to dt. Correct? So this particular question will change into t divided by root t, integral of this one, or integral of, so I, right, t power minus half dt. So if you integrate this one, you'll get t to the power of half divided by half plus c. So what is t? T is the denominator, correct? So you will finally end up with I is equal to 2 times root of 2x square plus x minus 3 plus c. This is going to be the final answer. Understood? Now, in the next one, we'll look into the ninth one. 5x minus 2 by this one, correct? Again, what do we do? Numerator is a into derivative of denominator plus b, correct? So here, numerator is 5x minus 2, denominator is 3x square plus 2x plus 1, right? Now, let's use that formula. Numerator is equal to a into d by dx of denominator plus b, right? So, 5x minus 2 is equal to a into 6x plus 2 plus b. right? So if you equate the coefficients now, coefficient of x first will do. Coefficient of x is this. Coefficient of x is this because you have to multiply, right? That means you will get 5 is equal to 6a, the coefficient of x. So what do you get? A is equal to 5 by 6. You got the value of a? This is by comparing the coefficient of x, correct? Now what we'll do? We'll compare the constants. What are the constants here? Minus 2 is on the left side, and on the right side it is 2a plus b, right? So minus 2 is equal to 2 times 5 by 6, 5 by 3 plus b. Make sense? So since you have this one, what is b value? B is equal to minus 2 minus 5 by 3, which is minus 11 by 3. So a is 5 by 6 and b is minus 11 by 3. So the question now changes. Correct? The numerator is this, right? So numerator is what? 5 by 6 into 6x plus 2 minus 11 by 3. So we are going to do that now. All right. So we have I is equal to integral of 5 by 6 into 6x plus 2 minus 11 by 3 whole over 3x square plus 2x plus 1 dx. Split the integral. That means 5 by 6 into 6x plus 2 dx by this one 3x square plus 2x plus 1 minus 11 by 3 integral of dx by 3x square plus 2x plus 1. See, the first part is very easy to do. Take the denominator as t, done. Your job is done. But the second part is where you have to do whole square and do the whole thing again. Understood? So, see the second part. First part I'm not going to touch right now. Okay? Or if you want, we can just directly do it. One step you'll get the answer. See the first part, I'll just write it down. You'll get 5 by 6 into log of 3x square plus 2x plus 1. That's all. Very simple. So let's not bother about that one. Second part is where it's important. Right? See, second part, what we'll do, we'll take that 3x square plus 2x plus 1 whole square form, which is going to be, see, a square plus 2ab plus b square, right? Now, a value is going to be root 3x, correct? Next, b value is going to become 2 by root 3, all right? A and b value. So, a square plus 2ab plus b square, that's going to become, so you'll have root 3 whole square, sorry, root 3x whole square 2 into root 3x into 2 by root 3. This should be 1 by root 3. 1 by root 3 plus 1 by 3 minus 1 by 3 plus 1, which is nothing but root 3x plus 1 by root 3 whole square, correct? So, plus 2 divided by 3, right? So, this is going to be the next part. That is the second part. Remember, I'm just doing this part right now. Understood, right? So, how we are going to continue after this one now? You have minus 11 by 3 integral of 1 or dx by, so what do we have here? You have in the form of a square plus x square, correct? So, which is going to be root of 2 by 3 whole square plus root 3x plus 1 by root 3 whole square. right? Now what do we do? Substitution. Root 3x plus 1 by root 3. Call it as t. So root 3 dx is equal to dt, or dx is equal to 1 by root 3 dt, right? So this is going to become minus 11 by 3 into 1 by root 3 integral of dt over root of 2 by 3 whole square plus t square. Isn't it 1 by x square plus a square? So you will have minus 11 by 3 root 3, 1 by a, so root 3 by root 2, tan inverse t divided by root 2, and root 3 comes here, plus c. Root 3 cancels. So minus 11 by 3 root 2 tan inverse root 3 into root 3x plus 1 by root 3 by root 2, right? So if you multiply minus 11 by 3 root 2 tan inverse of 3x plus 1 by root 2. So the final answer now, like we'll combine the first part and the second part and together we'll write it. All right. You have 5 by 6 into log of 3x square plus 2x plus 1 minus 11 by 3 root 2 tan inverse 3x minus 1 divided by root 2 plus c. Clear? So this is your final answer. So this is the answer for the 9th one. Okay, now we'll do the 10th one. The 10th problem. So here in the 10th one, integral of x plus 2 by 4x minus x square, correct? So again, what do? We use the same method, right? Numerator x plus 2. So numerator is a into d by dx of denominator plus b, right? So x plus 2 is equal to a into 4 minus 2x plus b. So when you equate the numerator, as in sorry, the x value, the coefficient of x, 1 is equal to minus 2a. So a is minus 1 by 2, right? So when a is minus 1 by 2, now we'll calculate the b value. So 2 is equal to 4a plus b, but a is minus half. So 2 is equal to 4 into minus half is minus 2 plus b. So you get b is equal to 4. A is negative half and b is 4. So let's substitute this. Now you are going to get I is equal to integral of minus half into 4 minus 2x, correct, plus 4 by root of 4x minus x square. So you can write this as minus half integral of 4 minus 2x by root of 4x minus x square dx plus 4 by root of 4x minus x square, right? See, the first part is very easy. Take the denominator as t, you will get it, right? So you will get minus half dt by root of t. Now this one you need to do that. Remember the squaring the whole thing, but there is a problem. There is a minus sign. Take minus sign outside as common, then you need to do it. Make sense? So 4, take 4 outside, dx by root of minus of x square minus 4x, correct? So the first part, we'll do the first part later on. Okay, let's not worry about the first part. First we'll concentrate on the second part and then come to the first part. right? The denominator now, see the denominator what you have is x square minus 4x. So equate with a square minus 2ab plus b square. Equate, you will get a is equal to x, then minus 2ab is equal to minus 4x, or 2x into b is equal to 4x, b is equal to 2, right? Since you have b value as 2, we'll get x square minus 4x will be x whole square minus 2x into 2. Now b square, add and subtract. So plus 4 minus 4. Correct? So we can write this entire thing as x minus 2 whole square minus 4. So the integral now becomes only the second part. So minus 4 into integral of, so the numerator, it's actually just plus 4. So we'll write the minus sign later on. Okay. So you have dx over root of minus of x minus 2 whole square minus 4. Correct? So 4 integral of dx by root of 2 square minus of x minus 2 whole square. This is exactly what we have for sine inverse, isn't it? See, you can take x minus 2 as t. So if you take x minus 2 as t, dx will be equal to dt, right? So you can write 4 times integral of dt by root of 2 square minus t square, which is basically 4 sine inverse t by 2, right? So now what do? We take both of them together and we are going to add it. That's going to give us the final answer. Correct? So let's do the final part now. Minus half into 2t to the power of half, correct? Plus 4 sine inverse of t by 2 plus c, correct? So we need to substitute the value of t now, because in both the cases the t's are different, right? So for the first case, you have minus root of 4x minus x square plus 4 sine inverse. Now for this one, t value is different, correct? X minus 2 divided by 2 plus c. So this is going to be the final answer. Got it? This is the answer for the 10th one. Okay, now we are going to look into the 11th one. Look at the 11th one. See, 11th one, I'll show you another method here. Okay. See, look at the denominator. Yeah. So the denominator, what you have is x square plus 2x plus 3. Say you differentiate. Okay. So what will you get? You will get 2x plus 2. Correct? 2x plus 2. So you can write this as 2 into x plus 1. Correct? 2 into x plus 1. The numerator, we can change it as x plus 1. That is basically, we are going to take that x plus 2, write it as 2x, sorry, we write it as x plus 1 plus 1. So we are going to change it a little bit. Guys, it's actually the same form itself, but a little bit different, that's all. Alright? So here, the numerator, we can write the numerator x plus 2 as x plus 1 plus 1. Correct? So 2 into x plus 1 is basically the dt part, correct? Dx is dt. So this you can write it as half dt plus 1. Half dt plus 1. So what we are doing is, we are writing the same numerator in terms of denominator, but with respect to t. That's all. It's a small change, small variation. See, if you are not comfortable with this particular method, please continue with whatever we have been doing so far. Okay, that method is always, that method works every time. All right, this method also works every time, but it's easier if you have numbers like 1, 2, and 3 rather than half and 1 by 3, something like that. All right, now in this case, x plus 2 can be written as half of dt plus 1, right? So the numerator now is going to become, what we'll have is I is equal to integral of half of whatever we have, that is 2x plus 2 plus 1 by root of x square plus 2x plus 3. Split the integral. I is equal to integral of half 2x plus 2 by root of x square plus 2x plus 3 plus dx by root of x square plus 2x plus 3. Yeah. Now in this case, I is equal to half integral of dt divided by root of t, right? Plus dx by root of x square plus 2x plus 3. Okay. See, the first part, again, it's very easy. First, let's finish off the first part. So you have half t power minus half dt. So half into t to the power of half into 2. Cancel, just t power half, isn't it? This is the first part. Very simple. Let's keep it aside. Let's do the second one now. All right. See, the second part, you have integral of 1 by root of x square plus 2x plus 3. All right. Now, compare it with a plus b whole square. So you have x square plus 2x plus 3 as a square plus 2ab plus b square. Yeah. So you can compare, a value is going to be x, right? And 2x or 2ab is equal to 2x. So b value is going to give you 1, isn't it? Quite simple. So next, what do you have? So you can take x square plus 2x plus 3 as x whole square plus 2 into x into 1, because b is 1, plus 1 minus 1 plus 3, right? So group it, this entire thing, you group it. So when you group it, this is going to become x plus 1 whole square plus 2, right? X plus 1 whole square plus 2. So integration or the integral is going to become I is equal to integral of dx by root of x plus 1 whole square plus root 2 square. Correct? So let's take x plus 1 as u being some other value, like we don't want t again, right? So dx is equal to du, I is equal to integral of du by root of u square plus root 2 square. This is that log function, correct? So I is equal to, we have log of u plus root of u square plus 2, right? Now at the end, what we'll do, we are going to substitute these values. Fine. So log of u value is what? X plus 1, right? So at the end, what are we going to have? We'll combine that root t and this together, and then we'll do it. All right. We have I is equal to root t plus log of u plus root of u square plus 2 plus c, correct? So root of x square plus 2x plus 3 plus log of x plus 1 plus root of x plus 1 whole square plus 2 plus c. So this is going to be the final answer for the 11th one. Quite a big one, but these problems are quite long. Understood? So all these problems, whatever we have discussed so far, this is end of one particular part, that is the substitution part is done. Okay, in substitution only we discussed a lot of things, correct? So this marks the end of the substitution. That doesn't mean that we are done with it. We are going to apply the substitution later on also, but one part of it is completed. All right. So in the next video onwards, we'll start learning about another type of integration. Integration in the sense another type, another variation of solving integrals. All right. We'll do that in the next video.